And I want to invite Dwight to join us now to share his story on why he made a huge bet on the city of Milwaukee. Dwight?
Thank you.
Thank you.
I'm from Silicon Valley, and I'll try not to suck, right? So as they recently said, I came here in 1986, and this part of town was drastically different. We used to walk up here in the middle of the night just for sport and hope not to get mugged, but this was amazing. And so the new stadium, we saw that on Monday, terrific. I came to Milwaukee. I grew up in Minnesota. I came to Milwaukee for MSOE. MSOE showed me a university that had small classes, professors-led leading curriculum, professors teaching, and that was really suited my background, kind of what I excelled at in high school. And so when I came here, I interned here the last year in school. I interned with Alan Bradley, worked up in the clock tower and smart motor controllers, partnered with one of my professors, and it was a great experience. And if things had worked out a little bit differently, I'd probably still be here in Milwaukee, but ultimately, I left Milwaukee to move to Texas to work on personal computers. I wanted to join Compact Computers, and I spent a few years down there. Along the way, my boss left, moved out to Silicon Valley for the pitch of a startup company. That sounded pretty amazing, so I went with and got to move to Silicon Valley and joined a startup that was run by a bunch of bozos. It really didn't work out so well. But I got to Silicon Valley, and I knew what now a bad startup looked like. And ultimately, I moved to the side and joined NVIDIA about 25 years ago. I initially led the software team, created it. Today is just over about 4,000 software engineers. And so it's a wide spectrum of things that we do. We do everything from computer graphics for video games, for professional computers, to supercomputers, data centers, and now a lot of embedded AI at the edge type designs, whether it be robotics, drones, self-driving cars, or smart city implementations. And so the implementations of everything we do is pretty diverse. Along the way, MSOE kept in contact. I have a lot of classmates that I went to school with that are back here, obviously, professors I stayed in contact with, and I joined the corporate board back in the early 2000s, became a board of regents in the mid-2000s, and at the time when Herman Vietz, our longtime president, said, please join the board of regents, I asked him, well, what does this mean, and how can I help, because I live in California? And he said, I'm sure you can find ways to bring Silicon Valley innovation to MSOE in your own way. And so I never thought we'd get to this, but it ended up that way. And at NVIDIA, we've really went through the last 12 years or so, 3 chapters of artificial intelligence. We started out our company building graphics. Along the way, we decided that each and every pixel needed its own program, so that instead of basically setting up a texture map, applying a color, and lighting up each and every pixel, instead you could actually have a processor for each and every pixel on the screen. That led us to places. Number one, it gave us really great graphics. It made really feature-rich video games. But it also led to the part where GPUs became much more parallel computing efficient than CPUs. And around an inflection point, around 2002, 2003, people that were doing parallel processing or computational sciences took notice. And they said, well, geez, if I could use the GPU for general purpose computing, I could do some amazing work where CPUs were starting, the art of innovation of CPUs were starting to slow down as Moore's Law started to decline. And so we created this thing called CUDA, which was a C++ construct to allow these developers, instead of going through our texture map registers and our GPU registers to ultimately do 2 + 2 = 4, we had a whole new interface to our GPUs so that when you didn't want to use it for graphics, you could use it for computing. CUDA took really the computational science space by storm. Every bit of technology out there, whether it is chemistry, whether it's astronomy, whether it's molecular dynamics, all of those have a computational science background. Each of those backgrounds all have compute codes that take an enormous amount of computing power to solve their real-world problems. These computing codes can take months to complete. They can take many days to complete. And all of a sudden, when they ported to CUDA and they ported to our GPUs, the accelerations they showed were basically roughly 50x, 100x, 35x. And it transformed things that used to take months to days, days to hours, hours to real time. And with that, we took over all of HPC. We democratized high-performance computing. And once when Intel said there's no way that GPUs will ever be in the data center, we're now pretty much in every data center around the world, starting with HPC. And then some magic happened because of that. In 2012, there was a student at the University of Toronto, Alex Krzyzewski, he's now famous. He basically had no idea how to do computer vision, but he knew how to build deep neural nets. It was a new type of technology. It's really the cornerstone of what artificial intelligence is. And when he knew that if he could get this working, he might be able to solve computer vision techniques that have never been done before. People have been working on computer vision for decades, but historically they have only achieved low 70% success rate. Humans can detect computer vision at around 92%. So while computer vision has been used for manufacturing for decades, and we had it when we went to school, it wasn't always that great. And so some things it works well, but the cameras have to be just perfectly aligned. It wasn't that great. So Alex had the idea on how to get his deep neural net up and running on a supercomputer. The only problem is he didn't have access to a supercomputer, and when he finally found one that maybe would give him access, he couldn't afford it. So instead he drove to Buffalo, New York, bought 3 GPUs from the Best Buy, smuggled them across the border without paying the goods and services taxes because they're cheaper, and ultimately got his deep neural nets running on a GPU and showed the world that all of a sudden his computer vision, there's a yearly competition, his computer vision scores were in the low 90s, almost approaching human levels. And all of the major research universities took note. The following year, 4 different universities all submitted GPU-based deep neural net, computer vision-based code, all achieving in the mid to high 90s, transforming computer vision as we know it. And then the race was on. Everybody said, wow, because they published it, and I think the CEOs earlier were talking about by publishing results and all these things, all of anybody who had a very computational-based workload took note and said deep neural nets could solve many problems. And probably the 2 main industries that really took note back in 2012 were the computer industries, computer service company, or computer software companies, internet software companies, who have many large-scale things going on in the cloud, and the computing horsepower just wasn't enough. If you think back to 2012, and you'd say, okay, Google, you had to repeat yourself about 4 or 5 times, and it still didn't work. Right? But ultimately, they switched over to deep neural nets running on GPUs in the data center, and now it works perfectly. They actually excelled over Apple. That Siri took a little bit too long running not natural language processing, and so now everybody's shifted. They realize that's the way to do it. And so all this innovation has happened. We've worked hard to accelerate artificial intelligence. In the last 6 years, since Alex Krzyzewski first released ImageNet, we've increased artificial intelligence performance by 600x in 6 years. Within the 10-year period from 2012 to 2022, we'll accelerate AI performance by 10,000x in 10 years. And at the moment, in the past, when you write software for a living, you knew that you had Moore's law on your side. You could do nothing, and your software would get twice as fast in 2 years because of Moore's law, that there'd be more transistors into the CPU. Moore's law for CPUs are dead. However, with the new computing model being a parallel computing-based approach using AI, we now have seen this enormous acceleration of deep neural nets, and now all of a sudden, we go to the 3rd chapter. The 3rd chapter, which is really exciting, I think, for Milwaukee, is AI for industry. If you think about what is software, software is about automation, and AI is about automating software. So it's really automation of automation. In the end, not everybody knows how to write software. It takes a special person. You have to go to school, you have to be good at software, and it's still not everybody graduates and wants to work on software. But in terms of AI, you don't need to be a software engineer. You just need to know how to teach. Many people have children. They know how to teach their children how to walk, how to talk. They basically train the neural net model. That's good, that's bad, that's good, that's bad. And over time, the child walks really well or talks really well. That's not unlike a new model, the deep neural network model, where you just need to train it with millions of images. And once you do, your neural net's going to do some amazing software writing that humans could never do. We have purposely went off to build our self-driving cars because it's the mother of all AI challenges. Our shipping implementation will probably have about 30 concurrent deep neural nets running at the same time. If we can make that work, we can make all kinds of things work. So coming back to AI for industry, you think about, and I know Milwaukee's good at many things, and this is about collaboration and innovation, but if you think about what drives AI, or what drives Milwaukee's economy, you have medical tech, you have manufacturing and logistics, you have financial services and analytics. All of those are ripe for AI and analytics, AI and accelerations, and they're all being used today. There's many startups that are doing it, but who makes more sense to implement all these things? Some startup in Silicon Valley, or right here in Milwaukee where the domain expertise is here. You guys can train your neural nets much better than where the guys are just knowing about supercomputers. And so we were really excited about that. We ultimately been working with John Waltz, our new president of MSOE, since he joined, about creating a new computer science program that would really focus on all the pillars of acceleration of AI. And we've been doing that right about pretty much all of 2017. We announced in October, we created this new degree. We're really excited. We wanted to have 25 new students join. We had just over 53, and I think the enrollment for next year is going to be a lot more than that. As you've seen, maybe you've already seen the construction. We're building this building. This building is going to have a supercomputer. All the students are going to be trained in AI, trained how to build neural nets. And while it's exciting for the computational science team, the computer science degree, it's going to be even more exciting when we can transfer that to some of the skills that MSOE has, and that it can basically be AI for all the degrees and classes there. And so we're really excited about what that brings to Milwaukee, what it brings to MSOE, and that's why we did it. Thank you.
Thank you, Dwight.